Welcome to Let's Calculate Something. Today we're going to use calculus to solve an interesting practical problem. We have a box here and we have to ship it, say UPS or something. And the requirements are that the perimeter, the length of the base, perimeter of the base, plus the length can't be more than 96 inches. And so if we want to ship something in bulk, the weight doesn't really matter. It's a bulk shipment, so we can cram as much into that box as we can. So let's maximize the volume so we can get the most value of our shipping. So following this constraint here of 4x plus L being 96, what's the maximum volume we can ship? And the way we're going to calculate that is we're going to figure out what the formula for the volume is. We're going to relate one of these variables into that formula. We're going to take the derivative of it. We're going to set that equal to 0. We're going to solve for x in this case. And then we're going to know the base. And then we can easily get L. And that's going to tell us the dimensions of a box that will have the greatest volume. So let's get started. So let's start with this first formula, and that is 4x plus L equals 96. And then if we want to find the volume of the box, that is just the volume equals x squared times L. So that'll be the area of the base times the length. So those are our two formulas that we're going to work with. So being that we have a squared term here, let's solve this one for L and then plug that into this equation. So we get L equals 96 minus 4x. And let's plug that in here, and we get the volume equals x squared times 96 minus 4x. And if we multiply that through, we have the volume equals 96 x squared minus 4x cubed. Okay? So we'll bring this up, and then we'll take the derivative of this, and then we'll set that equal to 0. Then we'll be able to find our max. Okay? So let's move this up. Volume equals 96x minus x squared minus 4x cubed. And the derivative of that with respect to x equals 192 x minus 12 x squared. So that's bringing this down, then reducing it, bringing this down and reducing it. And that is our formula. So now we can take that and set it equal to 0 and then solve this equation. And we can factor out a 12x squared from this. So we can get 0 equals 12x, or 12x, I'm sorry. And that would be whatever 192 into 12 is. I think that's 16. So we have 16 minus x. Okay. Then we can divide this by 12, and that 12 will go into 0, so that'll just go away and get rid of that. And we have x equals, so we have x times 16 minus x equals 0. We know x can be 0. There's two solutions here, and x can be 16. Either one of these will get us a 0. But we don't want x to be 0. So we know x is 16. So let's write that right here. Use a different color. This is 16, and then that is 16. There's a 16 there from another tape. And so now we have x equals 16, so let's find L. We know that L from this formula equals 96 minus 4x. Sixteen times 4 is 64, so L is equal to 32. And that's L. Okay, so let's be consistent, sorry. Let's make it 32. So now, if we want to find the volume, we can use this formula over here. And the volume is going to equal 16, which is x squared, times 32, and the volume that'll give the maximum volume we can have is going to be 8192. And that's our answer. So to ship with maximum volume, we're going to have a box with a base of x equal to 16, square base, 16 by 16, 32 in length, okay? That satisfies this requirement here to 96. And the volume that gives us is 8,192 square inches. And that's our answer. Thanks for watching. Please subscribe. Please click the notification so you can see more videos that we do. Please like and comment. If you put a comment in, then we appreciate that. If you want to give us some more problems to do, we'll solve those for you and post them in the comments. And then we'll also put them on our video occasionally. And if we do, we'll give you credit for it. So thanks for watching. We'll see you next time.